China shipped 5,500 humanoid robots last year. Do you want to know exactly how many Tesla shipped? 150. Seriously. Elon Musk stood up and promised 10,000 units, and he delivered 1.5% of that goal. Meanwhile, a Chinese robotics company called Unitree is casually targeting 20,000 units in 2026. I mean, the public narrative is completely blinded by hype and wild CEO promises, but the stark reality is hiding right there in the actual production numbers. Exactly, Marcus. The global humanoid manufacturing war is well underway, and China is winning it by a margin that should genuinely shock people. Welcome to today's Explainer. We are cracking wide open this unseen production war. Here's our roadmap for today. We're going to start with the production war itself, and then bring it all together to examine the massive geopolitical and macroeconomic stakes involved. Right. But before we get to the macroeconomics, Maya, we absolutely must break down the precise engineering tolerances and specs of the top competitors. We have to look under the hood first and dig into the silicon and the quantum sensors powering this whole revolution. Because when you look at the raw shipment data, the sheer scale of the gap is mind-blowing. Like I said, Tesla promised 10,000 Optimus units for 2025, but they shipped roughly 150. And most of those, they were just deployed internally at their own gigafactories. Then you look at Unitree's performance. 5,500 units shipped. Tesla's entire humanoid project is currently being lapped. You have to understand, in robotics, whoever is shipping more units is learning more. It is entirely a learning rate game. Every single shipped unit feeds real-world data back to the mothership, and that compounds rapidly. Section 1. The Humanoid Production War and the Absolute Race to Scale. To really grasp what's happening here, we need to answer one very basic question. Why human-shaped machines at all? Well, it's because the physical world is already built for human bodies. Think about it. Doors, stairs, hand tools, they are literally all designed for our height and our grip. So the humanoid is the ultimate universal end effector. But right now, there are two violently conflicting manufacturing models attacking this opportunity. The Western model is all about precision perfectionism. Perfect the engineering, get the robot to a flawlessly high level of capability in a strictly controlled environment, and only then try to scale it slowly. It's quality first, volume way later, right? And then you have the Chinese model, which is pure mass production dominance. The philosophy is ship now, iterate in the field. Just get it good enough, ship it at a massive scale, and improve faster than your competitors can even blink. And from a business strategy perspective, historically speaking, this volume-first approach creates an unbeatable supply chain moat. Once you control the actuators, the gearboxes, and the sheer assembly capacity, your competitors simply cannot compete with you on price. Section 2. Engineering specs and the competitors. Let's actually look under the hood. I love digging into these raw numbers. Because as an engineer, what fascinates me is how these top players are targeting entirely different sectors of the economy. So you have Tesla's Optimus and Unitree's G1 fighting it out on general purpose utility and price. But then consider the American company Figure AI. Their Figure 01 robot is strictly targeting enterprise B2B. They secured a massive partnership with BMW for structural insertion tasks. We're talking about incredibly repetitive factory work that demands extreme dexterity. Then, on the completely opposite end of the spectrum, you have the Norwegian company 1X with their Neo Humanoid. They are aiming squarely at the residential market. They're designing a robot with soft physics, compliant materials, and lower power actuators specifically meant to safely navigate the totally unpredictable messiness of a human home. Okay, but to be fair, Marcus, when we look closely at the Tesla Optimus Gen 2, that FSD heritage really matters here. Oh, I'll admit, the engineering pedigree is incredibly solid. It stands 168 centimeters tall, weighs 57 kilograms, and boasts 28 degrees of freedom. And yes, repurposing a decade of real-world full self-driving data for bipedal locomotion is a massive architectural advantage. But the unavoidable reality is they only shipped 150 units. And because of that massive miss, they are scrambling. Tesla has actually discontinued Model S and X production lines at their Fremont factory specifically to retool and prioritize Optimus mass production just to try and catch up. And while Tesla scrambles, you really have to marvel at the Unitree G1. Their dynamic control is just staggering. Listen to this. At China's Spring Festival Gala, watched by literally hundreds of millions of people, G1 humanoids executed autonomous kung fu routines and 3-meter aerial flips. No safety tethers, no hidden remote controls. That is a live national broadcast. You cannot fake that. It's a massive engineering feat. With an entry price sitting around $16,000 and a target of 20,000 units for 2026, the price-to-capability ratio they are achieving right now is wildly ahead of the curve. Section 3, the NVIDIA Physical AI Stack, the hidden engine running the whole show. So, you might be wondering, how are all these different companies suddenly making bipedal robots walk and reason at the exact same time? We have to shift our focus downward, to the silicon. NVIDIA has effectively built a physical AI data factory blueprint, and it is beautifully constructed layer by layer. Step 1 is the Vera-Bluin architecture. This delivers a massive 10x inference jump per watt. Robots desperately need real-time compute on a very limited battery life, and Vera-Bluin solves that constraint perfectly. Step 2 is the brain. Step 3 provides the virtual training grounds. And Step 4 is the Newton 1.0 physics engine, which provides highly accurate mathematical models for collision and material dynamics, ensuring that the training actually mirrors real-life physics. Let's look a bit closer at Steps 2 and 3, though, because how do these robots actually translate those mathematical models into real learning? How do they even understand what we want them to do? That is Project Groot. These are Vision Language Action, or VLA models. When you casually tell a robot, hey, pick up the red mug, Groot translates that natural language directly into precise physical joint movements. But here's the crazy part. They don't learn this by dropping thousands of real coffee mugs in a physical lab. They train inside NVIDIA's Cosmos world models. These are hyper-realistic synthetic environments where a digital twin of the robot can fail and fall 1,000,000 times over a simulated weekend, perfecting the exact movement before it ever touches the physical world. Section 4, Quantum Sensors in Robotics, the unseen frontier of surgical precision. Now, I want to take you to an unseen frontier in physical automation that goes entirely beyond walking humanoids. It's a profound convergence happening right now in surgical precision. 94%. I really want to pause on this massive statistic for a second. This is the estimated reduction in collateral nerve damage achieved by the new Da Vinci quantum surgical robot compared to their legacy systems. We're not talking about a cute 15% improvement here. This is a categorical, life-altering transformation in patient outcomes. So how does it actually do it? The Da Vinci Quantum uses nitrogen vacancy center quantum magnetometers, which sounds like sci-fi, but these are essentially targeted defects in diamond crystals. They detect the microscopic magnetic signatures of neuroelectrical activity in real time, mapping out nerve bundles with millimeter accuracy while the surgery is happening. And what is truly fascinating from a market dynamics perspective is that this quantum integration goes way beyond just the operating room. Right now, quantum optimization algorithms are solving NP hard path planning problems for massive fleets of 500-plus warehouse robots. It's literally eliminating logistical bottlenecks at an incredible scale. Humanoids paired with quantum computing is easily the most underrated tech trend of the next 5 years. Section 5, the geopolitical outlook, which brings us to the macroeconomic and geopolitical reality of all this, because we have to ask, who actually wins when automated physical labor becomes the new global standard? The data here is staggering. In 2025, Chinese manufacturers controlled 90% of the global humanoid market share. 90%! Exactly. And because Western nations are stubbornly prioritizing perfection and quality over raw scale, they risk repeating exactly what happened with semiconductors decades ago. If the West becomes entirely dependent on Asian supply chains for critical robotic components, like the actuators and the quantum sensors, the strategic risk is absolutely immense. You simply cannot claim domestic manufacturing independence if 40% of the critical parts inside your factory's robot are imported. Yeah, but you're missing the point on the timeline, Marcus. When does this actually hit human jobs? That's what people want to know.
That's a fair point. Here's the exact timeline we're looking at. From 2026 to 2028, humanoids deploy in structured industrial environments. We're talking battery sorting, repetitive assembly. Then, from 2028 to 2032, we hit the commercial wave. Warehouses, restaurant kitchens, cleaning services. This is where real labor displacement hits meaningful scale in our everyday lives. Finally, 2032 and beyond is the domestic wave, where consumer-grade robots actually enter our homes for elder care and chores. Basically, anything involving repetitive physical labor in a structured environment is highly exposed.
So the safe ground for human employment over the next decade is complex human interaction in very messy environments, empathy, varied skilled trades, deep contextual judgment. The humanoid race is moving at breakneck speed right now, driven by relentless manufacturing in the East and absolutely brilliant silicon architectures in the West, which leaves us with a stark warning about the future of our own labor. As these machines scale up from the factory floor to your living room, I want to leave you with this final, provocative thought. In a world where a robot can theoretically execute any physical action you can, what task should a robot never touch? Think about that. Thank you so much for joining us for this explainer. Keep learning, everyone. We'll see you next time.